In the next video, I want to demonstrate how you can solve exponential equations that are in a quadratic form. They are disguised a bit. You're going to have to be on the lookout for this form, and I'll try to demonstrate to you what's going on in this. So we're solving equations involving multiple exponential expressions, and we're going to try these using the quadratic form and using factoring techniques and possibly the quadratic form if factoring doesn't work. So here's what we're looking at. We're looking at an exponential equation with multiple exponential expressions in it. This one is very unique because it's got this quadratic form. Now here's how we get it in the quadratic form. We've got an e to the 2x plus 2 times e to the x equals 8. So the first thing I'm going to do is I'm going to transform this into e to the 2x plus 2 e to the x minus 8 equals 0. Now here's where they start getting the idea of a quadratic form. I can take this and use the exponent rules. It's e to the x raised to the second plus, this is 2 times e to the x raised to the first minus 8 equals 0. Okay, now this is the flexibility of these exponent rules that you're going to have to be capable of doing. If it's 2 times x is your exponent, you can write that as a power to power. We haven't changed the value of it, we've just changed the look of the expression. Now, in order to make this a little bit more, hopefully, more meaningful and easier to follow, I'm going to let u, I'm going to do a substitution, I'm going to let u equal e to the x. If I replace all the e to the x's with a u, you can see where it takes on this quadratic form, because e to the x, replace it with a u, becomes u squared, plus, take out your e to the x, it's going to be 2 times u, then minus 8 equals 0. This is where they get the concept of it's in quadratic form. If it's in this quadratic form, what we can do is we can solve this either by factoring or quadratic formula. And this one I believe factors pretty easily, so it's going to be a u and a u. Signs have to be different, plus and minus. Factors of 8 that'll give you a positive 4. Well, I better make that a positive or positive 2. Positive 4 and a negative 2 equals 0. And if this is the case by using the zero factor theorem, that means u is going to have to equal either a negative 4 or u is going to have to equal a positive 2. Now I come back and say, well, it didn't start off as a u in this equation. The u really represented another expression, which was e to the x. So we take and replace the u back with the original value of e to the x. And e to the x would have to equal a negative 4, or our e to the x would have to equal a 2. And now we have to solve these resulting equations. So to undo an exponential of base e, I'm going to use a common logarithm. So I'm going to use the log property of equality and so take the natural log of e to the x equals the natural log of negative 4. On this side, natural log and exponential base e are inverses, so x would equal the natural log of a negative 4. This is problematic because you can never take the log of a negative number. So this solution is an empty set, or there's no solution coming out of this one. So we're going to disregard this solution. This has an empty set for us. We're going to go over here to the other one, and that says that e to the x equals 2. So perform the same strategy. To undo exponents, you do logarithms. So natural log of e to the x equals the natural log of 2. And then bring down your power rule if you want to do that. And take the natural log of e equals the natural log of 2. And what is the exponent you raise e to get e? And that is 1. So last time I canceled out and said they're inverses. They're still inverses here, but this is just another demonstration. This is equivalent to 1, and 1 times x is x, so x equals natural log of 2. So our answer should be the result of the natural log of 2. So we punch in the natural log of 2, and our answer is approximately 0.69. So x is approximately 0.69. Okay, what we want to do with these also, and I haven't been doing it very carefully throughout the entire lesson, but now that we're getting to some of these that it's going to matter, I want to reinforce making sure that you check your answers and make sure they work. So is there going to be any problem if we put in a 0.69? If I take 2 times 0.69 and raise e to that power, that's not a problem. If I take e to the 0.69, that's not a problem. So that answer should fly. You can go back and check it in the entire equation, and that means we're going to take second e to the x, and we're going to take 2 times, and I can put in our answer, since I still have it in there, times the answer, plus, okay, now I got to get out of that. I want to be an exponent, plus 2 raised to, or times e raised to the answer, second answer. Get out of there. And if I hit enter, it should equal 8. Bingo. Okay, so that's the first go around with a quadratic form. The next quadratic form is even more advanced. There's a quadratic form in here. If I rewrite this as 4e to the 4x plus 8e to the 2x minus 5 equals 0. Now, just like I did last time, I want to use the flexibility of these exponents. This is the same thing as 4 times e to the x raised to the 4th plus 8 times e to the x squared minus 5 equals 0. And then we're going to use this substitution to help us with recognizing that this is really an exponential form. So u is going to equal e to the x. So I'm going to replace all these e to the x's with u. So it's really going to be 4 times u to the 4th plus 8 times u squared minus 5 equals 0. Pardon the interruption, got a little phone call. Maybe supper's ready. Ah, what a good wife. She has supper ready for me. So I'm going to finish this up and then I'm going to go have supper. So what we want to do is we want to try to factor this. This is in a quadratic form and this is a more advanced quadratic form, but this thing factors as well. The factors of 4 that we could use are 4 and 1 and 2 and 2, so I'm going to use 2u squared and another 2u squared. The signs have to be opposite, so one's plus and one's minus. The only factors are 5 or 5 and 1. I want to end up with a positive 8u squared, so I want a positive 5 here. I want a negative 1 there. And if you double check all the FOIL, the outsides and the insides, you still get your 4u squared. You still end up with a negative 2u squared, positive 10u squared, that's a positive 8u squared, and you still have a negative 5. So all of that works. I'm going to try to get rid of those, so I don't need those cluttering anything. Equals 0. Now we're going to use our zero factor theorem. We got two numbers that multiply together give you 0. That means 2u squared plus 5 has to equal 0, or 2u squared minus 1 equals 0. Solving these for u, we got 2u squared equals a negative 5, which means u squared has to equal a negative 5 halves, which means u has to be equal to plus or minus the square root of a negative 5 halves. That is kind of nice because as soon as we take the square root of a negative, we know we have non-real solutions. So u, this part of the solution was going to give you non-real answers, so no real solution, and we're looking for real solutions, not imaginary ones at this point. So this part of this we can disregard. On the other side, though, we've got 2u squared minus 1, which means 2u squared has to equal 1, which means u squared has to equal a 1 half, which means u has to equal a plus or minus the square root of 1 half. We can take the square root of a positive number, so both of these are in the running. But what did u stand for in the beginning? U was representing e to the x. So e to the x has to equal a plus or minus square root of a half. To solve an exponential equation, now we apply our logarithm. We're going to use a natural logarithm to get rid of the base e. So natural log both sides, plus or minus the square root of a half. Kind of keep that in brackets since that's the argument. The natural log reduces with the exponent base e, so x has to be the result of the natural log of either a positive square root of a half or the natural log of a negative. Negative square root of a half. Of these two, this one can't be done because you can't take the log of a negative, so we disregard that answer. So in the end, we come down to one possible solution, that's the natural log of the square root of a half. So to get our decimal approximation, we type in the natural log of, got a square root, I want a square root instead, so let's try that again. The natural log of, now second square root of 1 half, so 1 divided by 2, parenthesis. I guess I don't need the parenthesis because it already did that, so delete. And now parenthesis for my logarithm, the argument, enter. And we get a negative 3.5 approximately, so x is approximately negative 3.5. There's our solution. So what I've done is I've gone through, I haven't checked that. It would be wise to go back and check, especially when you write it down wrong, negative 0.35. So instead of this, it should be a negative 0.35 I don't know what's wrong. I never can get that off the calculator right. But now you should be able to plug that back in to the original equation, which you come back up here to the original, and run that through. To cross our T's and dot our I's, you would take 4, and you take it times second e, where is that? E raised to the 4 times our second answer, then plus 8 times second e to the x, and we want to take it to the 2 times our answer, and that should give us 5. Got it. Okay, so they get a lot more sophisticated, and we're going to have to be up to the challenge because these are going to be challenging. Don't be afraid to ask. I'm really anticipating that we may have some questions here as you go through these. So we'll get right down to work, and we'll do what we need to do to make sure you can be successful. So there's some good examples for you.